Hello and welcome to topic 7. This is about shapes, area, surface area, and volume. We started by looking at parallelograms and rhombuses. In 5th grade, we do the area of rectangles, so we're going to expand this in that we're going to take our rectangle and just tilt it a little bit. Students took notes on one of these foldable pages, and we talked about the area will be base times height. We had used length times width in previous years, but most of the formulas involve a base and a height, so we're just going to call them all base times height. So we're going to look at a few problems here. Here's the notes we took just in case your child did not get it. They can go ahead and fill that in and try to understand a little bit better. All right, so we looked at an item such as this. Forgive my drawing, they're definitely not the best here. All right, so this is a parallelogram because it has two parallel sides. Two sets of parallel sides. So these guys are parallel and these guys are, well, kind of parallel. And it just means they're train tracks and they're going to never intersect. When you do a parallelogram, it's the same as a rectangle because really you could cut this piece off and move it over here and it would give you a rectangle. Okay, so that's the reason. If you cut this here and moved it, you would have the same figure as a rectangle. So I have asked that students always write the formula. This will give them 1 point on the quiz and test. Then I've asked that they show me what numbers they're plugging in. So the 10 is the base and the 21 is the height. Then they need to solve the problem. So this is 210. And then to get the 4 points that this is worth completely, inches, and because we're multiplying 2 inches, it becomes inches squared. This is how they will get full credit on the assessments. They will need to show the formula, what numbers they plugged in, and the final answer with units. We will be using calculators on the test and quiz, but we're not using them in class because I believe the kids should practice multiplying. So here is another parallelogram, and sometimes they, instead of putting the height inside, they put the height on the outside. So this is our base, the 5. This is our height, the 12. Again, I expect to see the formula, so area equals base times height. The base is the 5. The 12 is the height. That gives us a total of 60. And it would be centimeters squared. So for full credit, they must show the formula and the numbers being plugged in and the answer with units. I have gone over that multiple times. Not all of them are listening, so just repeating it one more time. From there, we took what would be a rectangle, and if we cut it in half, we formed a triangle. So the next item or next figure we looked at was a triangle. This one we've been doing for a while, and it is our base times height, but because there's the rectangle, but we cut it in half, and so it's 1/2 base times height. In this problem, we're going to keep the 1/2. Our base is the 4, and our height is the 2. You could do 4 times 2, get 8, and then divide it in half, which would be 4. Or half of 4 is 2, 2 times 2 is 4. You can do whatever you want, but only half one number, either the total of this or just one of the numbers. Some of the students are halving everything, so be careful with that. And then this is 4 feet squared again, because it is a foot times a foot. And again, I expect to see the formula, the numbers plugged in, and a final answer. Now, most of the students are happy with this kind of triangle, but not all triangles look like that. And let's see if I can get something here that looks, we also have these kind of triangles. In a triangle such as this, students have to be careful that this is not the height or the base, and this is not a height or a base. It needs to make a 90-degree angle to be considered the height. So this one's going to be our height. This is our base. So if our base is 4 and our height is 7, okay, we're going to again write our formula. So area equals 1/2 base times height. We're going to keep that 1/2. We're going to fill in our base of 4 and our height of 7. Half of 4 is 2, and then 2 times 7 is 14. You could have done 4 times 7 is 28 and cut that in half. Either way, you're going to get the same answer. And this one we're going to say is inches. So to get the complete amount of credit, inches squared. All right, so that is another type of triangle. That one would be an obtuse triangle because one of the angles is bigger than 90 degrees. And we did talk about that. That was also a 5th grade standard. We don't have to do that again, but students should know the name. Here's another triangle. This one would be an acute triangle because all the angles are less than 90 degrees. Here is 5 centimeters as our base. But again, it cannot be the slanty sides. Instead, what they do is they give us a height inside. And this height is going to be 9. And I'm just making these up. So again, we're going to write the formula. 1/2 base times height. So 1/2 times 5 times 9. In this case, I don't really want to split any of those, so I'm just going to go ahead. 5 times 9 is 45, but I need to cut that in half. So we're just taking 2 goes into 45 how many times? 2 goes into 4 2 times, which is 4. Bring down the 5. 2 goes into 5 2 times, which is 4. Bring down 1, and we have to remember to add that decimal, bring it up, and the 0. When we bring down the 0, 2 goes into 10 5 times, and we are finished then. So 45 divided by 2 is 22.5, and again, centimeters squared. And that was the triangles. From there, we moved, actually, let me show you, before we move on, let me show you what we did with triangles. We had something like this. We talked about how when we take a rectangle and split it, we form 2 triangles. And so we took notes on that. We took the formula. And then we did talk about the acute triangles, the right triangles, and the obtuse triangles. And we did a few examples. Alrighty. And then we moved into trapezoids and kites, and this is where students were not very happy. So here we go. So for a trapezoid, this is where there is only one pair of parallel sides. So this was one that we talked about last year again. So for a trapezoid, let's look at something, let's look at this. So here is my trapezoid. Okay. We have one 90-degree angle in this one. And then over here they show us that this is 8, this is 12, and this is 6. Okay. Now, there are two different ways to do this, and I'm going to show you both on this one problem. Okay. The first thing that you do want to figure out is if this is 6, this, from looking up here, is just 12. So this total amount is 12 plus 6, which is 18. Some students are struggling with figuring that piece out there. Now, you can look at this as a rectangle, well, actually, rectangle, it is in rectangle here, and then a triangle here. If we do that, the area of the rectangle, we know is going to be base times height, because we always show our formula. The base is 12, and the height is 8. That would give us 96. But we also have this triangle.